Então, se usarem o VM, o novo, com o OVA, que eu posso passar com o disco, há uma coisa só que vão ter que fazer, isto é igual. Isto é o mininet aqui a correr, já vos mostro. E eu tenho aqui a máquina que é a mesma do ano passado, só que eu estive a converter só para este formato. Tive que fazer uma nova e usar o disco. Enfim, não interessa. O que é que tenho que fazer? Isto no VMware, como são duas máquinas e nós vamos ter que falar de uma máquina para a outra, porque numa vão estar a correr o mininet. O mininet não é mais do que um programazinho que utiliza o OpenVSwitch, que é um switch virtual que existe no kernel do Linux, que é usado, por exemplo, por hypervisors. Se estiverem a usar o Linux, o KVM, ele usa o OpenVSwitch como switch para interligar máquinas virtuais entre elas e as máquinas virtuais ao sistema anfitrião, por exemplo, mas tem outras utilidades. E o Mininet é um programa que foi feito pela Universidade de Stanford que basicamente usa instâncias do OpenVSwitch para simular redes. Portanto, lança N instâncias do OpenVSwitch, é como se eu tivesse switch, porque aquilo é um software que funciona como um switch. Okay? Só que é um switch especial. Por exemplo, no nosso caso nós vamos estar a usá-lo e ele nem sequer está a fazer switching. Nós é que vamos ter que o programar para fazer switching. Nós é que vamos ter que vamos ter que instalar regras lá de maneira a que aquilo funcione como um switch. E isso está numa máquina... Isto podia estar instalado aqui também. O Mininet até existe um pacote do Ubuntu para ele. Vocês podem fazer sobre o apt-get Mininet e aquilo instala o Mininet. Mas assim é mais interessante porque fica mais próximo de um sistema real. No sentido em que vocês têm a rede a correr aqui dentro desta máquina virtual. Depois vão ter o programa que fazem a correr aqui dentro desta. Aliás, não é nesta, desculpa, é nesta aqui de baixo. Esta é outra que eu tinha aqui. Mas não foi preciso, porque tenho esta já pronta. Que era a do ano passado. Isto era para fazer uma nova aqui, se fosse preciso. E, portanto, nós temos aqui o que vocês vão programar, que se chama o controlador, e depois tem aqui a rede, o que vai ser controlado. Nós ainda não demos isto na teórica, ok? Mas qual é a ideia aqui? Nós vamos usar um protocolo que é o OpenFlow. Nem sequer é dos mais usados, não é assim muito dos mais usados em termos industriais. Nós vamos falar noutro que é o RESTconf e o NetConf, que são mais usados. Mas também são fundamentalmente diferentes, ou seja, o RESTconf e o NetConf usam os dispositivos que nós estamos habituados e são protocolos que são usados para enviar a configuração que vocês têm estado a fazer até agora. Ou seja, são protocolos, são APIs, são southbound APIs que eu posso fazer um software que utiliza aquele protocolo para descarregar configurações para dentro dos equipamentos. Mas são as configurações como nós tivemos a ver, ou seja, configurar VLANs, configurar os protocolos de encaminhamento, configurar BGP, seja aquilo que for. Ou seja, o que nós tivemos a fazer no CLI, a mesma coisa, mas automatizado. Este OpenFlow é mais radical. Ok? Isto é uma filosofia mais radical de programabilidade. O equipamento não tem protocolos nenhuns. Ou seja, o equipamento não tem o BGP, não tem OSPF, não tem nada. Tem que ser o meu software que faz isso tudo. A única coisa que o equipamento tem são tabelas a dizer que quando chega um pacote com determinadas características faz estas determinadas ações ou estas determinadas instruções. E nós no trabalho vamos seguir essa abordagem. Então, isto vai ter aqui um projeto em Java, que é de um controlador, que tem uma implementação do OpenFlow, portanto, permite-vos fazer um programa em Java que consegue mandar mensagens OpenFlow para os switches. E nós vamos programar uma funcionalidade muito simples nos switches. Vamos começar por fazer o switch ser um switch, ok? Porque o programa que eu vos dou, o que diz ao switch para fazer é todos os pacotes que recebe envia por todas as portas. Portanto, basicamente é um hub, ou seja, está a fazer como se fosse uma ligação física. Portanto, tudo o que aparece numa porta ele envia para todas as portas, menos aquela de onde recebeu. Portanto, obviamente que eu vou conseguir comunicar entre coisas que estejam ligadas àqueles switches porque eu estou a fazer flood para todo lado. A ideia é ele deixar de estar a fazer flood e passar a estar a fazer switching. Primeiro passo. Segundo passo, fazer switching com limites, ou seja, vocês só vão deixar um host falar com dois hosts ao mesmo tempo. Quando ele tentar falar para o terceiro host já não vai dar. E depois tem uma terceira fase que já não tem a ver com switching, que é se for tráfego TCP, e só se for tráfego TCP, vocês vão recolher as estatísticas das ligações TCP. E o OpenFlow vai permitir fazer isto tudo. Ok? Mas isso, antes de lá chegar, o que é que nós precisamos? desta máquina virtual. No site podem fazer o download da versão VMware. Se quiserem a versão do OVA, eu ou tenho que pôr lá um link para a Dropbox ou do Google Drive ou qualquer coisa assim, ou então tenho que pedir para tirar aqui do meu disco ou tirarem com uma pen. Porque já não há o VMware. Tem lá um vídeo que está feito com o VMware, portanto aqui eu vou fazer com o VirtualBox. Temos as duas máquinas, elas precisam de comunicar entre elas. Sim. Essa é do VMware, sim. Porque eu ia substituir pela da VirtualBox e não pôr a outra, mas agora entretanto vi que não cabe lá, portanto vou deixar na mesma aquela, vou só mudar o nome do link, vou deixar na mesma essa para VMware, porque pode haver que ainda tenha o VM Player e escusa de estar a usar outra coisa, mete no VM Player e acabou. A outra vou pôr outro link, só que o link não vai ser para o servidor, porque no file system que está lá não dá. Vou ter que pôr no Google Drive ou no OneDrive e pôr um link partilhado ali para se tirar. Aqui, se for no VMware, é muito simples eu falar entre máquinas virtuais, porque, por omissão, o VMware Player já faz isso, ou seja, já está num modo de rede que é NAT, ou seja, faz tradução de endereços, dá um endereço à máquina virtual, faz tradução para o endereço do host, para poder ir à internet, e também faz bridging entre as máquinas virtuais. No VirtualBox não é assim, e a máquina que eu vos vou lá pôr não está logo assim. Vocês vão ter que fazer o quê? Aqui nos settings da máquina, vão ter que vir aqui ao network, e aqui no network vão ter que pôr NAT Network, que não está. Mas quando vocês escolherem NAT Network, vão ter que ter aqui um nome, que também não vai estar, e ele vai dizer aqui em baixo uma mensagem que a configuração não é válida, porque não existe um nome. Para que exista um nome, vocês vão ter que criar esta NAT Network. Como é que a criam? Primeiro, têm que ter a certeza que estão aqui em Expert e não em Basic. Se não vos aparecer a opção, isto é aqui em cima. Estão a ver aqui? File, Tools, e depois tem aqui Network Manager. Isto só aparece se vocês tiverem o VirtualBox no modo Expert. Se estiver no modo Basic, não aparece. Onde é que vocês podem mudar isso? Ou quando instalam o VirtualBox, ele pergunta se querem o modo básico ou o modo Expert. Vocês devem pôr o modo Expert. Se por acaso não puseram o básico na altura, como é que mudam? Vêm aqui também ao Tools, ok? Não vão ter estas opções todas, mas vão ter aqui umas opções. Aliás, também vão ter aqui as Preferences. Aliás, vêm aqui às Preferences. No Windows não há de estar aqui, mas há de haver um sítio onde tem as Preferences. E nas Preferences podem mudar aqui, estão a ver? De Basic para Expert. Se tiverem Basic, metem em Expert e depois quando forem àquele menu, depois de porem aqui em Expert, quando forem a este menu das Tools, já vos vai aparecer o Network Manager. Neste Network Manager, eu já fiz uma NAT Network, estão a ver aqui? É só criar no Create, ele faz tudo sozinho. Se vocês carregarem no Create, ele mete aqui isto com este nome e define aqui qual é que é a subnet. Estão a ver? O que eu estou a fazer aqui é ter uma subnet, que é 10.02/24. Todas as VMs que estiverem a correr, que eu diga lá que pertencem a isto, vão ter um endereço da rede 10.02, estão a perceber? E conseguem falar entre elas. E como é NAT, também conseguem sempre fazer NAT para o sistema anfitrião, no meu caso o macOS, no vosso caso o Windows ou o que for, onde tiverem o VirtualBox instalado, e vão conseguir ir para a internet ambas, embora no mininet vocês não precisem que ela chegue à internet, não vão precisar de fazer nada na internet. Na que tem o controlador, pode-vos dar jeito ter a internet, que é porque vocês estão lá a programar, escusam de estar a passar para o sistema anfitrião, por exemplo, para ir a um browser ver qualquer coisa. Podem usar o browser que está lá na máquina virtual para ver qualquer coisa na internet. De resto, também de fazer downloads não vão precisar, porque já lá tem tudo o que é preciso. Ok? Portanto, vão ter só que criar aqui isto e depois nas definições dela vão ter que ir aqui ao network. E depois de já estar ali criado aquilo, podem então dizer que aqui no network ele usa, aqui tem as várias opções, normalmente ele está com NAT, que é o que vem por omissão aqui no VirtualBox, mas NAT as máquinas virtuais estão isoladas umas das outras e só conseguem falar para a internet através do sistema anfitrião. Metem NAT Network, têm as duas coisas, têm NAT para falar, para irem para a internet e têm uma network que ele fez interna entre as máquinas virtuais. Ok? Eu vou passar para inglês porque está ali o vosso colega de Erasmus, está bem? E até fica depois com a gravação. Sim.
Essa máquina virtual, as pessoas disponibilizam, nós temos que
Já tinha dito. Okay, so the virtual machine in the site, the version that I have in the site is, despite saying that is for VirtualBox, here in Labs, despite saying here that it is for VirtualBox, it's not. It's for VMware. Okay, I'm gonna put another link for the VirtualBox version, but it will have to be from Dropbox or Google Drive because the server downstairs doesn't support files this large because it's formatted in FAT32. So the files must be 4 gigabytes or less. So I'm not able to put this file there. So, as I was saying, you need to, I'm going to say it again in English really quick, you need to go to File, Tools, Network Manager. In the Network Manager, you need to create here a NAT network, which will be automatic, and then in the virtual machine, you need to go to Settings, and in the network, select NAT network with the network that we just created. No, it's in VirtualBox. In the preferences, you should have basic or expert. Okay. So if you have network manager, that's okay. That's not a problem. Okay. So now I have them running, both of them. You see here. This is Mininet. Mininet doesn't have a graphical interface. It's just an Ubuntu server without graphical interface. Because we are not going to work inside of this machine. I shouldn't have done this. I'm going to put it bigger. The resolution is bad here, okay? But you only need to do the login, which is Mininet, the password, Mininet, and then you need to check the IP address. So the only command that you need to do here is either ifconfig or IP space addr. Both commands give the IP addresses. In this case, it doesn't. You can see it here, but it's 10.0. It's 10.0.2.4. Okay. And then you just leave this machine running, and we do everything in the other one. Okay. So in this other one, which probably is here in full screen. Oh, this was for my big screen, so I'm going to try and change the resolution here. Or better so, I'm going to put this in. Okay, it's better to do it like this. And then again like this. Okay. So, I have this, I'm going to leave it here, it's no problem. So, what we will do is, this is I think it's a Ubuntu. And it has Eclipse installed with the project that you need to change, okay? Which is this. I'm gonna explain this in a minute. I'm just trying to put this smaller because I changed from a desktop monitor, and now this is too big here. This is too big for here. Okay. So. I'm gonna exit this. So exit. So if you see here, this is a terminal that I opened in the controller VM, but the prompt says Mininet at Mininet VM. Okay. Why? Because I did an SSH from this machine to the other machine. Okay, so that I don't need to touch the other machine is running, but I will do everything in the controller machine. So I remotely connect to the Mininet machine to launch simulations and to work. So you only need to start the VM, check the IP address to do the SSH, and that's it. I'm going to leave just to show you again. You see, now I am in the controller, PFA at Ubuntu. By the way, the user is PFA, the password is also PFA. Okay, so what I did was this, SSH. This is to have X forwarding. Okay, you will see why. Because Mininet launches switches and then launches virtual hosts. And if I want to have a terminal to work on those hosts, it needs to open a terminal window. So, and Mininet doesn't have a graphical system, so that's why I do an SSH from here, and I receive the X forwarding, so it will open a terminal window in this virtual machine, but that is connected to the host that's being run on the Mininet machine. So 10.0.2.4 was the IP address of the Mininet virtual machine. Okay? The password is Mininet, and then I am again here in the Mininet machine. Okay? So now you have a terminal on your Mininet machine, and you're all set. I have another terminal here for my machine, because I also needed to check my own IP address, which is 10.0.2.15. So both machines were placed in the net network, which was 10.0.2.0/24. One is the .2, the other one is the .15. I don't know why the gap. In your case, it might not be .2 and .15. It might be something else. But it will probably be the same network, because when you do the create network, VirtualBox creates that network. You can change it if you want for something else also. Okay, so this is basic setup. We have both VMs, either in VMware, and if it is in VMware, if you still have VMware Player or VMware Fusion in macOS, you can use the one that I have in the site. You can also It is also able to import the Mininet VM from the site, which is an OVF, but VMware Player also opens OVFs. Okay, it is also able to import OVF files. So in the VMware, you don't need to do this net network thing, because by omission, VMware already does a network between all the VMs and net. And if you are using VirtualBox, you need to do those configurations that we saw. Then, the project. We are using a controller which is quite old, but it's simple. That's why we are still using it. I'm probably going to change this for next year, but this year I wasn't able to fully do it yet. To another controller which is used in real service providers, which is ONUS. But it actually is quite similar, okay? So, although this one is much older, the other one that I'm talking about also is in Java, and the structure is even similar in many things in the terms of the program itself. Actually, because Floodlight was on the base of ONOS. So ONOS is now a little bit cleaner in some things. Some things have changed, of course, but the base of ONOS for OpenFlow was this implementation of Floodlight. So that's why it's very similar in several ways. Of course, it has different objects and different classes for the same things. But it's pretty much the same kind of organization in terms of project. So this has a lot, you see here a lot of packages, you see? All these packages are already implemented. This is an open source controller, so we have access to all of the code, okay? If I want to develop my own app, which is what we are doing here, I need to create my own package, which is already done here in the virtual machine, okay? You see here, net floodlight controller CGR module. So this is our own module, okay? But we have all these modules here, okay? You see here the core module, and then you have models for DHCP servers, for firewalls, for forwarding. Actually, this one, we have to do something because this forwarding package would do what? Switching, and we need to do our own switching with our own rules, so we don't want to use the forwarding one. Okay, so I'm going to show you that there was a code that I had to place here so that the packets arrive first in my module, in our module, and only after our module are they sent to the forwarding module. See? Because otherwise, we would tell the switch to do something, and then the forwarding module of Floodlight will do the switch. Would tell the switch to do something else, and it wouldn't work. Okay. So you have here a lot of inclusive, you have here a learning switch. So you have here a lot of things, and you can look at the code. You see here, I can see how the learning switch is implemented in the controller. Actually, I tell you in the project description that you can come here and see if you want. We look for examples in the code of the other classes. For example, our module is inspired in this one. Okay, it's a very reduced version of this one because we don't want to do traditional learning. Namely, we don't want to use VLANs because it's harder. Okay, and we want to have limits for the host, which is something that doesn't exist in a normal learning switch. So the CGR module was basically built from this one, but I removed a lot of things, I simplified a lot of things because we are going to do a special learning switch. Okay, we are going to do a learning switch that doesn't look into VLANs, it only has one VLAN. And we are going to do a learning switch that only allows the hosts to communicate with two other hosts at the same time. And we are going to do a learning switch that looks at TCP, which is something that breaks every rule of the TCP stack, okay? Because we are looking at the max and then at the same time we will look at the TCP packets, okay? In case when it's TCP, and we will get the statistics of TCP, okay? But it started from here. So I started from here, I built another package, and then I built this module, okay? You see here, for example, I also have a map, but our map is only MAC address port, and in the other one it had MAC address VLAN port, because it considered VLANs, okay? So, in order for this module to exist in Floodlight, I had to change some files, but you don't have to do that. So there's a configuration file of the project where you say which modules you want to have. And if you are building a new model, of course you will have to add the new model to that file. But that's already done here. Okay? This package is not a module. Okay? I called it CGR module, but this util package is for classes that have utilitarian methods, okay? So this is not a module, it isn't a module that runs, but what happens is that this one uses things from here, okay? If you see here, I have an import of, I should have an import here. I don't know where it is, but it's here somewhere because this has a lot of imports. It's here, okay? You see, I import the net floodlight controller CGR module util here, so that I have access to this class. Why? Because this class is for you to have examples, and you can use the methods on how to create the open flow messages and all those things. For example, here it has a method to install rules in the switch. It has a method to remove rules. It has one to send packet out messages, and it has one to send packet outs based in the packet ins. I'm going to tell you what this is in a bit, the packet ins and the packet outs. And that's it, you see? So it has a method to install a rule, a method to remove a rule, and the methods to send packet out messages, okay? Either built entire by me or a packet out that's based in a packet in. The module. So it has a lot of imports. Some of them are giving warnings, but I'm not going to remove them. I didn't remove them because maybe you will use things that are in these imports and then they are already there. But for now, they are not being used, you see here. Actually, this one is a little bit stupid to be here because this is the learning switch, but It's not a problem. It's just warnings because these are imports that are never being used, you see, in this class. So this is a Java class. Let me see if I can show you this bigger here. So this is a Java class. It implements 3 different interfaces, you see here. One is the iFloodlight module. What is this? Every module that I have, all of them must implement this interface. This is how the controller works, you see. This means that every module must implement a series of callbacks, a series of methods that all modules have, and that serve to interact with the rest of the program, with the rest of the controller, you see. Then I need to be an IOF message listener, so I need to implement this interface if I want to listen to OpenFlow messages, which I want, and if I want to listen to switch messages, which are also OpenFlow, but there's a difference between both of them. This is for me to listen messages when the switch is already connected, and this is to listen to the messages that the switches exchange with the controller in the connection phase. You see, that's the difference. Or the connection or disconnection phase. Okay? So this one is important for me to be able to receive information from the switch after it is connected to the controller. And this is to receive information from the switch during the connection phase. So, since I implement a floodlight model, there's a lot of, you see, there's a lot of methods that I need to implement. Actually, these ones are from the switch listening, okay? And they are not doing nothing for now, okay? From the iFlood module, we have this startup that I need to implement, which is the first method that is called when the module starts, okay? It is not, we are not controlling this, okay? We build the class, we go to the file and say that the class exists in Floodlight, and then when we start Floodlight, it's a whole project. It has a main class, which is not this one. That main class starts up the whole thing, and one of the things that it does is call the startup methods of all modules that are registered. So when Floodlight starts, it will, at a given point, it will call the startup method, and it will pass this object, which is a Floodlight module context that has information about Floodlight. Okay? Then I use this Floodlight provider service, which is an object that is here declared somewhere. Okay? Here it is, Floodlight provider service here. That I'm not making the code that builds this object, okay? So there's some code in Floodlight that builds the modules. The code that builds the module is the one that creates this object, calls the startup, okay? And besides calling the startup method, it also initiates these things, you see? Here I only have them declared. Somebody is going to, when it builds this object, is going to pass a reference to this object, okay? And this object represents a functionality of the controller that has methods, for example, for me to register as a listener of certain message types. This is what I'm doing here. This is me saying, here I'm saying that I want to listen to packet in message, flow removed messages, and error messages. These are the 3 types of messages that I need for the functionality that I'm requesting, okay? So what is a packet in message? A packet in message is when a switch receives a packet, okay? It can have a rule there that says, when I receive a packet, I need to forward it to the controller. So it will have to pick up the packet, place it inside an OpenFlow message, and send it to the packet. This OpenFlow message is called a packet in message, okay? So it's the OpenFlow message that serves the purpose of sending packets from the switch to the controller. So the first time, if I don't have any rule, when this is connected, I'm going to install a rule which is match any forward controller. So the first rule that the switches have, it's a rule that says any packet that arrives, I'm going to send it to the controller inside the packeting message. The flow removed message is sent when a rule expires. Okay? So you're also going to need this because you are going to install rules on the switches and you will need to know when the rules expire to implement the functionality. So that's why I also have here the flow removed message. Then I will have the error message. Okay, the error message is just to receive errors. Okay, it's not for the functionality itself. Then I'm also saying that I want to be a listener of switch events. Remember from the other interface, the one that is messages exchanged while the switches are connecting to the controller. Why do I need to be a switch listener? Because for the TCP part, you will need to install rules immediately after the switch connects. Okay? So after the switch connects, you want to place a special rule there. So you need to know that the switch activated, the switch connected. Okay? So you need to listen for those type of messages. That's why there's the add switch listener this. So this means that this module also listens to switch messages. So if I am a switch listener, this means that I need to have these callback methods. Okay? This one is called if a switch is added. This one is called if a switch is removed. This one is called if a switch is activated. This is called if a port changed on the switch. So, for example, if a port went down. This is the switch change method and the switch deactivated method. In our case, you will probably just gonna use this one. Okay? So the switch activated is after a switch is added and already negotiated the open flow version. Okay, and it's all set to receive open flow messages. Okay, it's ready to receive rules. So this is called automatically by floodlight when this happens. Okay, when the switch was already registered, everything is okay. It's called the switch activated is called. This receives something that identifies the ID, the switch. Okay. By the way, in OpenFlow, switches are not called switches. Why? Because in OpenFlow, we don't know if they are going to be switches or routers or whatever. Okay, so there's a name for it, which is data path. But in practice, everybody calls it switches in the same way. That's why even here in Floodlight, although the object is called data path ID, then the name they gave it was switch ID. Okay. So we are going to use this object to install things in this specific switch. Okay, it's through this object that I can send, for example, rules for this switch with this switch ID. Okay, so this is the part for the switch listener. What about these messages? Packet in and flow removed. So this is the startup. I could do the logic all here. You see, this is listener. Then this is also starting another things. For example, I am what this is going to do, this get config parameters is this is going to load a file and use the things that are on the file, you see. But you don't need to worry about that because if in the file there's nothing, which is the case here, you see. If in this file there isn't a field with this name, then he doesn't do anything, okay? Only if it is different from null. So if it's different from null, this variable will have the value that's in the file. Otherwise, it will have the value that you give here, you see? In your case, if you're not going to use the file, you can change it here for the numbers that you want. But the idea is that in the startup, it can go to a file and initiate these kinds of things, you see? That's the idea of this thing here. So, but you see here, if there is nothing on the file, it won't do anything on this, and you can change it, you can hard code them here. And that's it. That's what he does in the startup. Then he calls the init. Okay? Actually, I don't know if this one is called first and this one or the other way around. But these are the first two that are called. Okay? In this one, you might need to add things. For example, here I'm creating an hash map to store for each switch. I have an hash map, and the key of the hash map is the IOF switch, so it's the switch ID. And then the value is another hash map, okay? And this hash map is representing the MAC table of this switch, you see? So each switch has its own MAC table, right? So I need to have one hash map, which is to get the hash map of a specific switch. And then in this hash map, then I have in this switch, this MAC address is available on this port. Okay? So another important thing is here I'm using the context to get the serverless implementation of this provider service. Oh, this is called first, okay? Here I am getting this value, okay? So this is called first, then startup. So it starts with init and then it calls startup. Okay? Switch service, because I also need the switch service, and that's it, okay? And then this info that will appear on the console that the CGR module started. Okay? So the other methods that are here, the only one that is important for us is this one, okay, and this one. These are methods that are called in the beginning, and they define in which order. For example, I have the switch has the rule, match any forward controller, okay? So when a packet arrives, it's going to send it to the controller. But the controller has all these modules, okay? And every model that has a message listener that is registered, that implements a message listener, will receive this packet in. Okay? These methods are to tell the order on which this is done. Okay? And what I'm saying here on this one is that I want my module to receive packet ins before the forwarding module. Okay? Before the forwarding module. Why? Because every model that is registered has a listener, can receive the messages, but the first module that receives the message can stop the message from reaching the other ones, you see? Because after I receive the message, I process it and then I return something to the controller. This is an object which is called the command object, and it can be continue or stop. If it is continue, the core module of the controller will send the packet into the next module. If I return command stop, then the core module will stop. You see? And this is what I want here. I want to receive packet ins before this module so that I can control if this is going to arrive to forwarding or not. Okay? And if you see here, this is the callback. This is the callback that is called whenever I receive an OpenFlow message. Okay? So whenever an OpenFlow message is received in the core of Floodlight, so Floodlight receives a message, it starts to call the receive methods of every module that is registered as a message listener. Okay? In our case, we are registered to listen to a packet in or a flow remove messages. That's why I only have this in the case, these two cases. And the error, remember, these are the three messages that I said I was a listener. Okay? So this callback returns a public command. Okay? So it returns a command object. Okay? So I see the type of the message. So I receive a message here, an OpenFlow message. With the get type, I get the type. Then if it is a packet in, I'm going to pass this into this method, process packet in message. I could do the logic all here, but it will be less elegant, okay? So we have a method here, which is the method where you are going to do your logic when you receive a process packet in. So basically you are going to change this method here and this one. These are the two methods that you're going to change. This one is called when I receive the packet in. This one will be called when I receive the flow remove. When I receive a flow removed, okay? So basically you are going to work on these two, and then you can build other methods if you need that are going to be called inside of process packet in message and process flow remove message. So what do I pass inside? The message itself, the switch object, okay? The switch that sends it, and the context, because I can get stuff from this floodlight context, okay? And then I return whatever this method returns. This method will also return a public command. And you see here, if it is an error, I'm going to return a command continue, okay? If it is in the process, in the flow removed message, return private command, I'm also returning command continue. So this flow removed will pass on to the next module. But in the process packet in, okay, it also returns a command. And what I am doing here is that I'm returning command stop, okay? Because I do not want the packet in to go to any other modules. Why? Because the other modules could install rules on the switches that will contradict the ones that I'm going to install here. And then it would not work and I wouldn't understand why, okay? There would be things appearing there that wasn't me that placed them there, okay? So that's it. Basically, this is it, okay? Without going into the OpenFlow details for now. So, these ones are not from implementation. You see, they don't have the override. These ones are to add in working with the hash maps, okay? So the idea here is that I have an hash map, which is switch, and the key is another hash map, and that other hash map is key, MAC address, value, port. Okay? I need to have one per switch. Remember that if I have 3 switches, and I'm talking from one host in switch A to one in switch C, and that message is going to traverse the 3 switches, I'm going to receive 3 packet-ins. Because every switch sends me a message, a packet-in message, okay? And the logic in the program is the same. I'm going to enter 3 times this method here. Okay, so I'm going to go to the process packet-in method 3 times, okay? I'm going to come here 3 times. What's going to change is this object here. And the packet will even be the same. So what I need to do is use this to go to the right hash map and install the port MAC address mapping in the right hash map of the right switch. Okay, so for now, what does this do? So first here is getting the import, which is actually I'm not doing anything with the import yet. That's why the warning is here. This is also unnecessary because we are going to use OpenFlow 13, okay? And what I'm doing here is that if the packet-in is from OpenFlow 12 or below, then I use this function. Otherwise, I do use this one, okay? In practice, we will always use this one because we are going to use OpenFlow 13. Okay, but I left it here like that. So this gets a port, which is the port where the packet arrived at the switch that is sending the packet-in message to the controller. Then I can get the Ethernet packet that comes inside the packet-in. I do this by using this context here, this object. You see here? Using this object I can use the flight provider service and get the payload of the packet in, which is an Ethernet packet. Okay. Now the Ethernet packet has a get source MAC address method, which gives me a source MAC, which is an object MAC address. This one gets destination MAC address, same thing, another MAC address. So if one of them is null, I'm going to put this with MAC address none. Okay, this is just a safety check. Then I'm going to see if the destination MAC is a reserved address. Okay, for example, it will not happen here, but I left it here. For example, if it is a BPDU from spanning tree, okay, it will be ignored. This is a bitwise AND, okay, not a logic AND. So what it does is it gets the MAC address bits and makes an AND with these bits. And if the result is this means that this is a reserved address, okay? So this is kind of like a mask. And if the result of the AND is that, I know that it is a BPDU, for example. So in that case, I'm going to ignore, okay? And I'm going to ignore and do return command stop. I don't want to do anything else with this packet in. This is finished. So if not, if it is a normal address, then I'm using the isBroadcast and isMulticast methods to see if this is a unicast packet or not. Okay? Because if it is a broadcast, what I want to do is broadcast. So send the packet back to the switch with a instruction to send to all ports but the one from which it came. If it is a unicast, then here is where you're going to do your logic. Okay? You have to learn the port. You see, you have to learn the port. Actually, all these things that I have commented here, usually I should have placed this up, okay? Because all of this here should be done inside this if, because all of this is for unicast packets, okay? So bear this in mind, okay? All this should be inside this if, okay? And only this should be out. This should be like this. But in the virtual machine it won't be, okay? You need to check the video again or what else if you don't remember. Because all these things that I'm saying that you should do here, this is for unicast this is all for unicast. This is all for unicast packets, okay? This is everything that this is all for unicast packets. So this would be everything here, okay? So this is what I do for unicast packets. For now, I'm not doing anything for unicast packets. And I am doing a flood if they are broadcast. But that's why it isn't like this, okay? That's why it isn't like this in the version I gave you. Because if it is like this, it won't do anything when you do a normal unicast. And you won't see anything working, okay? Because you see, if it's not broadcasted, not multicast, it enters here, and here I'm not doing anything, okay? If it's not, I do a flood. Okay? Since this is not with an else, I have no else here. For now, it is always flooding. Okay? So if it is broadcast, it should do other stuff. You probably will have other stuff here, and then you will add an else here, because you only want to do flood when it's a broadcast, okay, or a multicast, when it's not unicast, okay? For now, I cannot place the else here, because if I put an else here, then I only do this in FF packets, and what I'm about to show you, which is a ping, would not work because the ARP would go, because it's an FF, But then the ping won't, because the ping, it won't be an FF because it receives the ARP reply, and it already has the MAC, so it will be a unicast packet and not a multicast packet. Okay, here the flow removed. This is the removed message that I receive here. It has a lot of methods. You can try and check. One of them is the get match, which gives you the match of the rule, which is the match is the rules that say which packets are to be matched. Okay. So we are going to talk about all these things in the theoretical classes, but only not next week, only the week after. Okay. So, and you should start working on this. So I have here a lot of examples. Okay. On how to build stuff, and also on the project description I have links for the Floodlight Java docs. And actually here in the, if you use the Firefox of the VM, you have here this link here. I don't know if I have network here now. I should have. Yeah. I should have. Okay. Also, here what you are seeing here is the user interface of the controller. Okay. It's on localhost 2.80/UE/pages/index.html. This is also in the project description file. And you have here information. So active, it is up at 1 hour and 44 minutes. That's what I started it in my office 1 hour ago, almost 2 hours ago. You can see the switch, which now I don't have switches probably. It's not what I want to do. It's this. Topology. I don't know. Oh, here you have the hosts only. Why I'm not seeing switches? Because probably I set mininet. Probably I set mininet away. Yeah. Yeah, because I ended mininet. Okay. Nothing is running. Okay. So I'm going to stop this. I need to maximize. Okay. So the controller is running. You see here the console. I'm going to stop it. So Floodlight is a big project. It uses Maven. Maven is that tool to compile Java projects. But here the Eclipse in the VM is already configured for when you do run. It builds with Maven and then runs. Okay. So if you do changes when you run again, it will build the project again. Okay. And deploy it again, build the jar, and then run it. You can also run Floodlight on the terminal after you do the build here. In these messages, instead of appearing here, will appear on the terminal. So it's the same thing. So when I start, I'm going to close the consoles so that you see from fresh. So I'm going to run this. If you see here, this configuration is what I am using. Okay. And this configuration, if you go here, you see this is the configuration. It tells that where the main is here, the main class is, so that Eclipse knows where to start. Okay. You see, you could do other configurations. You see, but this is the one that we are using. Okay. So if you play and run. I have to save, okay, so because it's going to build again, and I did some changes here. It gives a lot of messages because all of the modules of Floodlight are running, okay. So I'm going to look for my messages, okay. So my message should be one that appears around here somewhere saying CGR model started. Here it is. Okay, you see, here is the module that gave the message. which is hours. Then another thing that I should look here is when I'm already listening for open flow switches, which is a message that's here somewhere. Here it is. Okay. Which is this module, the switch manager, listening for open flow switches on any IP on this port, from any IP connecting to this port, 6653. Okay, this is important. This port here is important. Okay. Now, I have no switches. I just have the controller running, no switches. If I go here to the controller, I have no switches, zero hosts. Controller started 1 minute ago. I have nothing. So I'm going to create some switches in Mininet. Okay, so I have this terminal that is connected to the Mininet machine. Okay, and I have here a command. This is also in the project description. Beware that this IP that you place here must be the IP of the machine, of the virtual machine where Floodlight is running. Okay? The port is also important. It has to be that port that I showed a few moments ago, 6653. You see? That's where he is listening for open flow switches, on 6653. So, sudo, because it has to run as a super user, the /e is for the environment variables to be passed on so that I can receive the X forwarding, okay? That's why that /e, capital E is needed. It's not, this has nothing to do with Mininet. This is just because Mininet must be run as a super user here, and I want to use the same environment variables from the OpenFlow machine, namely the display variable, okay? Otherwise, the X forwarding won't work. Then, Mininet, which is the command to start Mininet. Then, there are several ways to build topologies on Mininet. I could do a Python file and create a custom topology in Python. You can check how it's done in the Mininet website. Or I can use this /topo option, which builds specific topologies like trees and stuff like that. So in this case, I'm building a tree with 2 levels. So it's just one root and 2 other switches as leaves. Okay. This option /MAC is optional, but is to have the MAC addresses fixed. So this will give MAC addresses to the switches like 000000002, 0000001. You see, MAC addresses that are legible for us. Okay. The /X is to do X forwarding, so that when I open terminals for the hosts, they open in this -X is for Mininet to open terminals for the hosts. Okay. In this topology, he is going to place 2 hosts on each of the leaf switches. Okay. So there are going to be 4 hosts. Okay. This is to specify where the controller is. So this is a remote controller, because otherwise Mininet would use its own controller. The IP, which is the IP of the OpenFlow machine, and the port. And this last part is to specify that I want to use OpenFlow version 13. Okay? Because otherwise, the latest version of OpenVSwitch already has a version higher than 13, which changes some things. Okay? So, you will see that when I start this, you need to check if everything went fine here with adding controller. If you have an IP that's not correct or a port that it's not correct, it will give an error here saying unable to contact remote controller. Okay? So in this case, everything went fine. Now it is adding the hosts, and it's adding the switches, and it's adding the links according to the topology of a tree. Okay, now it's configuring the hosts and running terminals, okay, because of this option here. Since I am doing this in the mininet virtual machine and I did the SSH with the /y or y or /x options, okay, then I am able, because you see here I use this is for X forwarding. The difference between /x and /y is that with /y it is less restrict with the authentication. Okay. So you see it opened, you see here X terms here, it opened terminals for the hosts and switches in the machine of Floodlight. Okay, so now I have here, these ones are for the switches that are not very useful. Okay. But I have the ones for the hosts. Okay, so I have host 4 here. Oh, I can't. This is, the other ones aren't visible here now. I'm going to close these ones because I don't need these ones here. So I'm going to close the switch ones because I don't need them, and this resolution is not showing me the whole screen here. Now I have host 1, host 4, and I'm going to do it like this. View. VirtualBox is not as good as VMware in these things. Okay, like this, it works like this, auto size. Let me see if the full screen now is good. Yeah, okay. So host 2, host 3, okay? Host 4, host 1, host 3, host 2. And now I can do commands here, okay? This command, TCP dump, is the packet sniffer of Linux. Okay, what I'm saying here is that I want to see everything that is arriving on my Ethernet 0 interface, but I'm not on host 1, I'm not on host 4, I'm on host 1, so here I need to place host 1. Here it's host 4, okay, and I'm going to do here for host 3, okay. So the project, how it's now, it's forwarding every packet to everybody else. So what's going to happen is, if I do a ping from H2 to H1, I should only see the ICMP packets arriving here. Okay? And we will see that it arrives on all 3. Why do they arrive on all 3? Because what the controller is doing is, every time it receives a packet in, says flood to all ports. Okay? So these are LLDDP packets that we are receiving, because the controller, in order for the controller to be able to show this topology here, it has to find out about these links. How does the controller find out about these links? The switches connect, but they don't say which links exist. Okay? So what the controller is doing here is, there's a module, if you see here, there's a module which is called link discovery, that is sending packets. Okay, what is doing, it is constructing packets, and then is sending an instruction to the switch to send the packet through all links. You see, when this packet arrives at the next switch, I have a flow there which says any packet forward controller. So I receive the packet that I sent, I received it, and it says in which port it was received. And this is how Floodlight discovers the topology, okay? And this is why here I am seeing the hosts receiving these LLDP packets, okay? Because they are doing this, they are continuously being sent, so that Floodlight is continuously discovering the topology. So now we can see that we have these switches, 3 switches connected, okay? Which is what... They all have the same IP address because they are working on layer 2. okay, the MAC addresses, we can see in the topology, if you place the mouse, you can see the rules that are installed, and you can see there the match is empty, which is match any, and the action is output controller. So this is the only rule that the three switches have. Any packet that arrives is forwarded to the controller. Okay? You can also see the rules here, I think. No, it's the switch role. This is switch roles. I don't know if you can expect here. This is the connections. Storage tables. These are the modules that are working. You see here, our module appears here. That is working. Okay, so the first step that you will have to do is, now if I do a ping here, let me put this one so that you can see the ARP. If you pay attention, you will see that packets that are not LLDP will start to appear here. The first ones that will appear will be an ARP, and then the ICMP packets. So there's one missing. 1, 2, 3, 4. Okay. So I'm going to ping 4. The addresses here are always 10.0.0 and then the number of the host. So for 4 is 4. Okay. You see, all of them are receiving the SMP's echo requests and sending the echo replies. So everybody is receiving the ping. What happens is that the ones that are not the destination ignore it, okay? And the ping is working, okay? But it's working because this is working like a cross connection. So it arrives the switch. It arrives at the switch doesn't know what to do, sends to the controller sends back an instruction for it to send through all ports except the one from which arrived, and that's it. Okay, so the first thing you will have to do is start changing this code for it to be a switch. And for it to be a switch, let me stop here the stop the ping. I'm going to stop the controller. Just going to stop mininet. Mininet stops here, exit. Okay. If you have any once in a while, you might do mininet/clean to it's 2 slashes to be sure that there's no OpenV switches instances that was stuck running for some reason or stuff. Usually, when you have a clean exit, it won't happen. But if you start having problems, or if sometimes you mistakenly crash the VM, the mininet VM or something. Or abruptly close it, and it's going to do a power off, an abrupt power off, and you can have things that you don't know if they're working or not. So here is where you'll start when it's a broadcast and a multicast. So you will have to put an else here, and only do this when you don't come inside the first situation. And here you have to see what? First you have to see if you already know the source MAC. So you have to go to the hash map and do the hash maps and see if the source map already is there for this switch. If it is, then you already know the source. Then you go and check if you already know the destination. Okay? If you already know the destination and the source, you can install a rule. Okay? And when you install a rule, it will stop flooding, because instead of sending to everybody, no, it will send to the port that you already know. Okay? So if source map learn the port, so you have to put it in the hash map. If you already know the destination, you can start building a rule. And you also need to do this, which is send the packet out of the packet in. Why? Because OpenFlow works like this. The switching sends the packet in message, And then you have, if you don't send the packet in message back in the packet out, this packet is going to be lost. Okay? But for now is this, okay? These rules, you will have to take some things in considering when you need to do the whole functionality, because when you install rules based on max, then you will have problems with the TCP part. You will have to use different priorities. They are evaluated by priority. Because if you do, for example, imagine that you are doing a ping. A ping is not TCP. You are going to install a rule between MAC address A and MAC address B. So after you install a rule, you no longer receive anything in the controller. You stop receiving in the controller, because the rule now says, instead of forward controller, it now says send through that port. So you will stop receiving those packets. And now imagine that next somebody does a TCP connection between the same two hosts with the same MAC addresses. Okay, the TCP packets will also have will be inside an IP packet, inside an Ethernet frame that will have the same MAC addresses. That will match with the rule, so the controller doesn't know that the TCP flow started, and we want to know. So you will have to have a higher priority rule, which is TCP traffic still comes to the controller, and then you will have another set of rules with an even higher priority, which is after I receive the first packet of a TCP connection, I can then install a rule which is not only MAC address A to MAC address B, but is MAC address A to MAC address B with TCP protocol, okay, and install the rule and then get the statistics. Okay, but this will be clearer after we talk about OpenFlow and how OpenFlow works. Okay, so this is it in terms of starting the final part of the project. This is not difficult. It's difficult to get in, and once you see where you have to change stuff, even you don't even need to go a lot to these tutorials of Floodlight. You see here you have examples on how to create rules and all this stuff, and I think I also have here the Java doc of this. I don't know where, it's not here. This one no longer exists. Because this uses something which is flow, something like that. It's here in the tutorials. How to write a module. It's here. How to use OpenFlow J Oxygen. This is the Java doc. It has here a link for the Java doc, which has all the objects for. But I have examples for almost everything, and you can also see in the other codes of the controller how things are done. OpenFlow 1.3. The hell, why doesn't it? You see here how to process a packet in message. It also has all the things, how it's done. And you have all these things here. How to do matches, all these things are here. And you also have this one, the Java doc of these things somewhere, but probably it's best to open this on the other functional resources. Não quero iniciação nenhuma. I was seeing because I think there's a Java doc somewhere. I don't know if I have it here on the. I know I only have this. I have here, but this no longer exists. This does not no longer exist. This one. Okay, but you have in the tutorials you have examples for basically everything. Okay. Actually, if you check here, you have here how to make an instruction. You have everything here. How to install the rule. How to build this is different. This is no longer called CGRL2 switch. This is now called CGRL module. Okay, you have to adapt this, but you have all things here.